Hello everyone. Today we're going to learn how to do a DNA cleanup using glassmilk. Before we start, it's important to note that I'm not doing a full mini prep, although many of the steps are evidently the same. Here, I'm starting with an existing DNA sample. Specifically, I have 4 PCR products today that I need to clean up. Secondly, it's worth mentioning that glassmilk is a colloquial term for a suspension of silica powder in some buffer solution. Under the buffer conditions used in the cleanup, the negatively charged DNA will adsorb to the positively charged silica. Ideally, impurity molecules with a lower charge density will be removed during the washes. The purpose of this cleanup is to remove impurities from a DNA sample. There are a number of examples as to when we might want to do this. First, sometimes you need to do a digest reaction with 2 or more restriction enzymes that require different buffers. In this case, you would do your first enzymatic reaction, then do a cleanup, and then your second enzymatic reaction. Second, you might do a plasmid prep and then find that your product was of suboptimal purity. Rather than starting your prep again with fresh cultures, you might consider attempting a cleanup on your DNA sample. Finally, of course this list is not exhaustive, you may wish to clean up a PCR product mixture before starting a digest without running a gel, which is what I'm doing today. Now, that of course begs the question, why am I not running a gel on my PCR product? Well, I actually did run an analytical gel earlier to ensure that I got the right products. I'm not running a preparatory gel because gel extraction dramatically decreases recovery and because I'm going to be running a gel after my PCR digest anyways. And with that, we'll begin the actual demonstration.
Right here, I have 4 PCRs that I just removed from the freezer. I eventually need to digest these for insertion into a plasmid, which means I'm going to have to run a gel on them anyways to remove the excised fragments. In order to minimize my losses and save time, I'm not going to run a gel now. I'm just going to do a cleanup, and then after that I'll take these straight into a digest. You'll also note that I'm not working sterile yet. That's because I'm going to be cleaning up my DNA. I'm going to be washing with buffers containing guanidine and ethanol, so anything that would contaminate my samples is going to be removed and killed. So first, I'm going to begin by aliquoting out 100 microliters of glass milk into each one of these tubes that I've pre-labeled for my PCRs. We want to make sure that the glass milk's really well resuspended, so I'm going to vortex that first. And then I'm going to take 100 microliters of my glass milk, just keeping that suspended. And aliquot that out into each of these 4 tubes. In fact, I should just open those all now. It's important to note that there are many glass milk recipes available online. Some of them call for different weight or volume fractions of the actual glass powder with respect to the liquid. I believe that this is a 20% weight to volume suspension, so you'll want to adjust your volumes accordingly for the glass milk recipe that you're using. So after that, I'm going to take 1 milliliter of PB mini prep buffer. We prepare that ourselves. Again, so it's worth noting that I'm using a different volume here from what you would actually use if you were doing a spin column prep. Right. In a spin column, Quiagen's protocol suggests that you use a 1:5 ratio, 1 part of your DNA sample and then 5 parts of PB. But just from trial and error, I've found that actually bumping up the amount of PB that you use when you're doing these glass milk preps definitely helps with recovery. So again, I'm going to add 1 ml of PB to each one of these tubes. PB is an aqueous solution containing 30% isopropanol and 5 molar guanidine hydrochloride, and that's going to help our DNA bind to the glass milk. Okay. So I'll put that aside. Again, that's PB. Now we want to add our DNA samples. So these are 50 microliter PCR reactions. And I'll just aspirate them. And I'll pipette up and down a couple times just to make sure that I'm getting all of the DNA sample out. Okay, at this point we're going to want to give our DNA some time to adsorb to the silica. When you're doing this on spin columns, you typically just spin it down at a relatively low speed and your DNA binds to the whatever separations matrix is in the column almost instantaneously. With these, the adsorption is not instantaneous, so it's a good idea to put your DNA samples on a nutator plate for a few minutes, I don't know, maybe less than 5 minutes, in order to give them some time to adsorb. So I've removed my DNA samples after they've been on the nutator plate for about 5 minutes. If your glass milk begins to clump up, you can always vortex them intermittently to disperse the glass milk. It's not a bad idea to do that a few times anyways. But at this point we're going to want to spin these down to collect our glass milk pellets. So we're going to put these in the centrifuge at 4000 RCF. We're going to set the centrifuge to 30 seconds because that's the lowest that it can go, but realistically we're only going to need about 15 seconds to spin down all the glass milk powder. So I'll start that. The speed at which you spin down your glass milk depends on the mesh size of the glass milk. I don't really know of any scientific correlation for that, but I just know that the glass milk that we use can be effectively spun down at 4000 RCF. You can spin down at a higher speed than that, however your glass milk pellet will be more compact and harder to resuspend in future wash steps. So now we want to dump out the supernatant. Our DNA is adsorbed to the pellet, the silica pellet at the bottom. And I'm just dumping these into the liquid waste, a temporary liquid waste container. So at this point, you'll probably notice that there's a little bit more liquid left in there, and that's going to be PB that contains guanidine hydrochloride, and we want to get all of that out. So I'm actually going to put these back in the centrifuge briefly. I'm just going to give those a very quick spin. Let it get up to, maybe a couple hundred RCF. And I'll just use my P200 here to aspirate off the last of the PB from these. And I'll just eject those tips straight into the solid waste. You'll note that because these are all different DNA samples and I don't want to cross-contaminate them, I'm not using the same tip for all of these. If they were the same prep, so for example if I was just doing multiple mini preps of something in order to get more DNA, I would just reuse the tip, but I don't want to cross-contaminate these. Okay, so now that I've removed as much of the guanidine as possible, I'm going to wash these with PE buffer. This is the wash buffer suggested by Quiagen for use with their spin columns, but we found that it actually works quite nicely with the glass milk preps as well. And PE is, I believe it's 80% ethanol, buffered to pH 8.4 or 8.5 with tris. And at those conditions, the DNA will largely stay adsorbed to the silica. Again, we're not working sterile here because we're using an 80% ethanol solution. And I'm going to wash with, actually, I'm going to wash with 0.75 mils. It doesn't really matter because you're really just washing. We're not trying to achieve any specific stoichiometry here. Okay, now I'm going to resuspend these by vortexing right here. I think the most effective way to resuspend these by vortexing is kind of hold them together like so, so that when you put them on the vortex, they knock together, and that produces really good agitation and a very agitating noise. But after about 10 to 15 seconds, your silica is completely homogenized. You want to slowly rock that back and forth to make sure that there are no silica clumps left in there. If there are, then you'll want to put it back and vortex it some more to make sure that it's completely disrupted. If your silica pellet isn't completely dispersed, you're not going to have efficient washing. Sorry, I probably shouldn't talk while I'm vortexing that at the same time. If your silica pellet isn't completely dispersed, you won't have completely efficient washing, and then you'll have impurities in your DNA when you're finished. Now, after that's completely resuspended, we're going to put these back in the centrifuge, again at 4,000 RCF for about 15 seconds. And we're going to wash twice with PE. That was one wash. That ought to do it. Again, I'm just dumping out my PE into the liquid waste. Okay. Washing again now with 0.75 mils of PE buffer, or buffer PE as Quiagen calls it. Not quite sure why. Get rid of that, because I'm not doing any more PE washes. And again, I'm going to resuspend these by vortexing them. I'm allowing them to knock together in order to quickly resuspend the glass milk pellet. That looks pretty good. I'll resuspend the next two. There we are. Those also look good. Turn off our vortex. And again, we're putting these back in the centrifuge for 15 seconds. Start. Now after this, I'm going to wash with ethanol that I've redistilled. The reason that I've redistilled the ethanol is because our lab buys it in large 5 or 10 gallon carboys, and the quality of that material, it's fine for most things, like if you're just sterilizing your gloves like you've seen me do in other videos, or if you're wiping down your bench top. But it is a lower grade of ethanol, and it contains some grease. So what I've done is I've redistilled this, and actually just from distilling that volume, it's left behind about about a tablespoon of just higher molecular weight organic material. So, you know, depending on the ethanol that your lab buys, it's up to your discretion what you do. So the purpose of the ethanol wash is twofold. One, it's to get off the last of the tris that's in there. Tris is probably fairly benign, but NEB has specifically tailored the concentration of their restriction enzyme buffers, and I don't want to disrupt that by adding some exogenous tris. Alright, so again, I'm just washing with 0.75 mils of ethanol. Actually, it's not a bad idea, before we do this, to suck off the last of the PE as well, just like we did with the PB. So I'll put these in the centrifuge, spin it down for just a couple seconds. Alright. Aspirate off the last of the PE. The objective here is to remove all salts and other small molecules that might be in with our DNA. Now, it's not necessary to do a wash with the distilled ethanol, but I don't think it's a bad idea, so I do it anyways. Cap that. And again, we're going to resuspend these by vortexing. So just one last time, the way I'm holding these is just, two fingers there and then with my thumb, and then doing that allows them to knock together, and it's very effective. It's very effective for resuspending glass milk pellets. Okay, so now that those are completely homogenized, I'm going to put those back in the centrifuge and spin down the glass milk pellet. Should be good enough. So again, I'm going to dump out the ethanol, but this time we want to really remove all of the ethanol before we put this into some sort of enzymatic reaction, right? Because the ethanol will inhibit our digests or any other sort of enzymatic reaction. So after I dump these out, I'm going to spin this down at a very high speed to squeeze all the last of the ethanol out of the pellet. And then I'm going to leave my samples uncapped in a 50-degree oven for a few minutes to allow the last of the ethanol to evaporate. And that should be fine for DNA. Again, DNA is a very DNA is a very stable molecule. So I'll turn that all the way up to the maximum speed of my centrifuge, which for this particular one is about 21,000 RCF. And I'll just let that go for a couple seconds at maximum speed. Okay. So again, now I'm sucking off the last, or I'm aspirating the last of the ethanol. That was silly. I just dropped those into the liquid waste. I'll get those out later. Okay, so now, if you look closely at those, you probably can't see those on the camera, but our pellets are obviously still damp with ethanol. So I'm going to put these in a 50-degree oven, crack with the lids cracked open to allow the ethanol to evaporate. So I left my samples in a 50-degree oven open for about 5 minutes, and now these silica pellets are all dry. And while I was doing that, I took these four 1.5 ml tubes. They're sterile 1.5 ml tubes. They've been autoclaved in this container here. I took those out and I labeled them to match the tubes that I prepped from before. And the reason I did that was because we're going to elute our DNA in water, but just because of the geometry of the bottom of these tubes, it's very difficult to get out all of the silica. So first I'm going to elute in water, resuspend the silica, and then I'm going to transfer it to these tubes in order to spin down the silica before I move to the next step. Okay, so I'm going to take my P100. I'm going to elute each one of these in 50 microliters of water. I'm going to use autoclaved Millicue water as my nuclease-free water. And I have autoclaved tips here. So again, I want to open those close to the flame. And because I'm sticking my pipette into a theoretically sterile bottle, I'm going to wipe the barrel off with 70% ethanol. There we are. Okay, come on. There we go. There's our first sample. Okay, so now, even though it's a very small quantity of liquid, I found that a very efficient method for resuspending these is actually just to vortex them briefly. See, and that's formed little bubbles of liquid there at the bottom. Okay. And I'm going to do that with these other two tubes. Now, obviously this has splattered a portion of the liquid that contains my DNA now up onto the walls of the tubes. So I'm going to give these a brief spin down in the centrifuge, not more than a couple seconds. Not enough to pellet the silica, but just enough to get all of the liquid down to the bottom. Okay. There we are. Now I'm going to transfer my silica slurry, all of it, so it doesn't really matter what volume I set my pipette to. I'm going to transfer all of my silica slurry into the correspondingly labeled 1.5 ml centrifuge tube. This one says PCR1. You may have to pipette up and down in case you accidentally pelleted some of your slurry when you were centrifuging it earlier. we want to go ahead and get all of that into our 1.5 mil tubes. Excellent. So now I'm going to take these and I'm going to spin them down for 30 seconds at the maximum speed. So one thing that's important to note is that I've been working under a flame ever since I took those samples out of the oven. Before I put them in the oven, they had ethanol in them, so I didn't really bother working sterile. Of course, they're not canonically sterile after I take them out of the 50-degree oven. 50 degrees isn't hot enough to sterilize them or anything. But at the same time, I want to keep these clean now because I've just added RO water. I'm going to go into a digest after this, and I want to avoid any undesired nuclease contamination in my samples. And almost finished. So, as you can see, the silica has formed a very tight pellet at the bottom, and I'll be able to aspirate that off and move on to the next step. And with that, thank you very much for watching, and I'll see you at the next video.